Strainlabs solution is about sensorized bolts. As you can see on the rail, there's a sensorized bolt which clamps together two parts. Many of the parts in the railway industry are connected by bolted joints. And this sensor measures the preload in a bolt. And preload is fundamental for keeping the parts together. If there is no proper preload in the joint, then nothing else matters. The joint will sooner or later fail. And the pain point for the railway companies are that bolted joints do not maintain their preload over time. Sooner or later it will change, mostly because of dynamic loads, temperature changes, and so on. The industry is aware of this and must go out and inspect these joints. And there are several thousands of these joints and switches all over the country. And for each inspection, you have to be physically present. And also close down the traffic during the maintenance or the inspection of the joint. With this solution, you can see every single bolt that is connected to a railway section. And instead of having to shut down the traffic whilst you go on site and inspect the joint, it is done purely automatically, and that time can be used to increase track availability and green mobility. So this is the digital interface of our solution. Everything is built on a site because every single switch exists somewhere in the world. On the site, we have a particular switch or several switches, and each site has then several joints. Behind me we can see one joint over here and one joint closer to me. And in each joint there is a number of bolts. And the user can create a picture which is uploaded to this site so you can see exactly which bolt does what. Every bolt has a unique ID, which means it can be traced all over the world. And finally, there is a graph showing the complete evolution of the preload in the joint. If the preload is outside of an expected value, then an automatic warning message will be issued to the user, pinpointing the exact bolt and the exact spot where the problem is. This is also displayed over time, so you can always see what the evolution of preload and temperature is during day, night, or even over several years, so you can see exactly what is about to happen. So you can always go back in time, use, for example, data mining or machine learning to pinpoint what is the exact behavior of this joint over time and use that for future better designs.